Alright, let's look at the homework 4.6, problem number 6. Alright, it says that a parcel delivery service will deliver a package only if the length plus girth does not exceed 108 inches, 108 inches. Right, so that's the requirement. So let's look at the part A. Find the dimension of a rectangular box with a square end. So we have a rectangular box with a square end, so it's gonna look kind of like that. Alright, so let's say, so it's a square, so x, let's say x by x. Right, so length is gonna be L. Right, so the girth would be x plus x plus x plus x, so it's going to be 4x. So 4x plus length L, so it has to be less than equal to 108. So I'm going to actually set exactly equal to 108. How about that, to make it a little bit easier? Alright, so that's the requirement. And we want to find the largest possible box. So we have the volume V is going to be x squared times L. Right? So it kind of makes sense to solve this equation for L. So I'm going to subtract 4x from both sides. So L is equal to 108 minus 4x. Right? And we can just plug this expression in here, right? So we get, right, so x squared times 108 is 108 x squared, and minus 4x times x squared, so 4x cubed. Right, so that's the volume function. So we want to maximize that, so we're going to take the derivative. Right, so with respect to x, so derivative would be 216x minus 12x squared. Right, then I'm going to just factor out, I think we can factor out the 12x. Right, I'm hoping that so let's see, can I divide 216 by 12? Let's see, 12 and 96 and 8. Yep, so it's going to be 18, right, minus just x. Right, set that equal to 0. So you know the critical number would be x equals 0 and 18. Right, and we cannot have x equals 0 because x has to be a length that we want to be positive. So 18 is only reasonable critical number. Right, so it's probably, let's see, we are looking for find the dimensions of the largest box, and also the maximum volume. So 18 is going to probably give you the maximum box. Right, so the dimension is going to be 18 by 18, and so length is going to be, we just have to plug in 18 in here. So L is equal to 108 minus 4 times 18. Right, that's what? 108 minus 4 times 8 is 32, and 4 times 1 is 4, so it's a 72. So that's going to be 36. So it's a 36. Right, so dimension is going to be, so I'm just going to type in dimension of a rectangular box is, let's separate, so 18 comma 18 comma 36. Alright, so check that. Alright, we got that. Alright, the maximum volume is, okay, so we have to compute that. So what's that? So 18 times 18, 8 times 8 is 64, 1 times 8 is 8, so 114, so it's 18, 4, 2, 3. then we have to multiply by 36. So 3, 2, 4, 36, right? And 4 times 6 is 24, and 2 times 6 is 12, and 3 times 6 is 18, right? 3 times 4 is 12, right? 3 times 2 is 6, 3 times 3 is 9, right? 4, 6, 6, and we go up 1, 1, right? 11664, right? Right, 11664. Alright, let's check the answer. Alright, got that. Alright, then part B. Now we're talking about the different shaped box. It's a cylindrical container. So let's do that. So part B, and I'm gonna have to erase that. Hold on a sec. Alright, so now we are talking about the cylindrical container. So you have a circular end, then here's the length. Alright, so let's do the radius. So let's say you have a radius, and the radius is R. Alright, length is L. Alright. Then the restriction would be, so the girth would be 2 pi r. So 2 pi r and plus length L is equal to 108. Alright, then the volume V, based on, I'm going to actually step back a bit. V is going to be, alright, so the area is pi r squared. Then you have to multiply by length L. Alright, so it makes sense to solve this guy for us. So subtract 2 pi r. So L is equal to 108 minus 2 pi r. Alright, so plug it in. So it's a pi r squared times that, so it's going to be pi is a number, so, and it's 108 r squared minus 2 pi r squared, right? Actually, I messed it up, right? That's cubed, right? Because r squared, right? Then we can just take the derivative with respect to r, right? Pi just a number, put that there. And you have a 216r again, minus, in this case, 6 pi r squared. Right? Then we can just set that equal to 0. But we should factor out r, pi. Actually, 6, can I do a 6r? No, I can't do a 6r. So I'm going to just pull out just r. Then you have a 216 minus 6 pi r. Set that equal to 0. Right, we have r equals 0 from there. Right, from here r is going to be 216 over 6 pi. Can we simplify that? Divide by 3, 72 and 2. Actually, let's see. Actually, it's divisible by 6, isn't it? 3. Yeah, it was divisible by 3 for some reason. I didn't think that was going to happen. So it's actually simply 36 pi. Alright, so it's a 36 pi, so it's going to be the dimension wise, you're going to have, let's see, r is the 36 pi, so radius and height, so then r is going to be, L is going to be 108 minus 2 pi times 36 pi. Alright, oh, okay, sorry. I messed up. So it's a 36 over pi. Alright, 36 over pi. Sorry about that. Alright, so you can put, it actually makes my calculation a little bit easier. 36 over pi. Alright, So we can see that the pi's and cancel out. So you're going to get 108 minus, I guess, 72. Right? So that will be 36. Right? So we know that the dimension is going to be, right, 36 over pi. Right? Radius of cylinder. Check that. We got that. And the height of the cylinder is, what was it? 36. So we got 36. And check the answer. Got that. And the maximum volume is, let's see, so we have, let's see, R is given, so it's going to be volume when R is equal to 36 over pi. Is going to be pi. R is 36 over pi squared, and L is 36. Right? So that's going to be, let's see, there's 2 pi squared on the bottom. One of the pi cancel out. So pi is going to be on the bottom. And what's 36 cubed? I'm going to just cheat 36 cubed. It's 46656. 6656. Right? So let's do that. 4, let's see. Nearest cubic inches. Okay, so I have to find that. Okay. So, oops. Yeah. Alright, so it's going to be divided by pi. Alright, so you got, right, so 14851. Alright. Alright, this is 14851. Let's type it in. Let's see, I can't get that thing. Okay. So 14851. Alright, so let's check the answer. Alright, got it. Alright, that's it. I hope that this was clear.